good morning to all. This is Manvesh. Today my topic is about power electronics and motor drives in electric, hybrid, electric and plug-in hybrid electrical vehicles. So, so now the introduction. With the increasing demand for environmental friendlier and higher fuel economic vehicle, automotive companies are focusing on electric vehicle, hybrid electric vehicles, HEV, plug-in hybrid electric vehicles and fuel cell vehicles. These vehicles would also enable meeting the demand for electric power due to increasing use of the electronic features to improve vehicles performance, fuel economy, emission, passenger comfort and safety in electric vehicles, HEV and PHEV and fuel cell vehicles. The challenges are to achieve high efficiency, ruggedness, small size and low cost in power converters and electric machines as well as the associated electronics. In particulars, in fuel cell vehicles, a power conduction unit such as a DC to DC converter for matching the fuel cell voltage with the battery package may also be necessary in stir by wire and brake by wire application, a fast response motor inverter, and furthermore the integration of actuators with the power electronics not only improves the reliability but also reduce the cost and size, etc. In addition, the power electronics, the electric motors play a major role in the vehicle dynamic and type of the controlling the vehicle operating characteristics. So next, the HVSs. The HVS, the hybrid vehicles has two or more sources of energy and or two or more sources of power on board the vehicles. The source of energy can be battery, a flywheel, etc. The source of power can be engine, a fuel cell, a battery, a ultra capacitor, etc. depending on the vehicle configuration. Two or more of these power or energy sources are used. Hybrid vehicles save energy and minimize pollution by combining an electric motor and an internal combustion engine in such a way that the most desirable characteristics of each can be utilized. Hybrid vehicles can are generally classified as series hybrid and parallel hybrids. In a series hybrid, the engine drives the generator, which in turn power the electric hybrids. In a parallel hybrid vehicle, the engine and the electric motor are coupled to drive the vehicle. A series hybrid vehicles can offer low fuel consumption in a city driving cycle by making the ICE constantly operates the highest efficiency point during frequent stop starts. A parallel can have low fuel consumption in highway driving cycle in which the ICE is at point while the vehicle is running at the constant speed. The hybrid vehicles are divided into the power hybrids and energy hybrids according to the role performed by the engine and the transmission that system is designed. So this is the series hybrid vehicle propulsion. If you see, there are wheels over there, and in the construction you will see the converter, and you will see the 12 volts battery, engine control unit, and alternator, converter, high power battery, and system controller, propulsion control interface, and the drive interface, and the transmission and the electric motor, fuel tank. So now the series hybrid vehicles. The series hybrid vehicles, a typical configuration of series hybrid propulsion. A series hybrid vehicle is essential an electrical vehicle with an onboard source of power for charging the batteries. In general, engine is coupled to a generator to produce the power to charge the batteries. It is also possible to design the system in such a way that the generator could act also load leveling device that provides the propulsion power. In this case, the size of batteries could be reduced, but the size of generator and the engine need to be increased. The power electronic components of typical series hybrid vehicles systems are the converter of a conversion, the alternator output, the DC for charging batteries, and the second one is inverter for converting the DC to AC power for the propulsion motor. A DC to DC converter of a charging of 12 volt battery, in this vehicle as well as. In addition, electric air conditioner inverter are associated with the control system. So this is the parallel hybrid vehicle, the propulsion system. So if you see the same components that are included in this, that we are seeing in the series hybrid vehicles. So it's the same component that are repeated in also this parallel hybrid vehicles. So there is only one difference, that is the drive interface. So it was not there in the series hybrid vehicles. So it was present in the parallel hybrid vehicle propulsion system. So the parallel hybrid vehicles can offer the lowest cost and the option of using the existing manufacturing capabilities for the engine, batteries, and the motors. However, parallel hybrid vehicles need a complex control system. There is a various configuration of parallel hybrid vehicles depending on the roles of the electric motor, generators, and the engine in a parallel hybrid vehicle. The engine and the electric motor can be used separately or together to propel a vehicle. The Toyota Prius and Honda Insight are some examples of the parallel hybrid system which are commercially available. A typical configuration of a parallel hybrid propulsion system is illustrated. So next, that is PHVS. The PHVS can have been considered as a significant advancement of the hybrid vehicle technology in the both industries and the academia, and even by the government agencies around the world. PHVS have a battery pack of high energy density that can be externally charged and hence can run slowly on the electric power for a range longer than regular HVS, resulting in a better MPG. The battery package can be recharged by a neighborhood and outlet charger or in a garage. PHVS improve the utilization of utility power because the charging of batteries is done during night time. Representative architecture of a plug-in parallel hybrid vehicles architecture, that the conversion of conventional HVS into PHVS is being tired as a transit technology in many companies in order to enhance the efficiency of HVS. Moreover, the auto manufacturers are considering preparing for the introduction of PHVS into the commercial market. The conversion is achieved either by adding a high energy battery pack or by replacing the existing battery pack of HVS. In order to extend the all electric ranges, the high energy battery pack must be able to store enough electrical energy from external from regenerative braking and must be able to supply the stored electrical energy to the system. So AC outlet charging should be invertible, need a battery charge composed of an AC to DC converter with power factor correction and programmable digital control with a proper voltage current profile. For the higher energy battery packs, a bidirectional DC to DC converter and a charge discharge profile is also necessary so as to transfer energy from batteries. Traction motor system to make PHVS available to regrade to using a great number of high battery charges with PFC at the same time, and the choice safety, thermal management, and cell balancing of high energy batteries such as NIMH and lithium batteries for automotive applications are some of the important issues. So next, the fuel cell vehicles. A fuel cell vehicles system designed for the vehicular propulsion application must have a weight, a volume, a power density, a startup, and a transient response. Similarly to present ICE based vehicles, other requirements are the very high performance, short time and rapid acceleration, good fuel economy, easy to access, and safety consideration with respect of fuel handling. The cost and the expected lifetime are also very important consideration. A typical fuel cell vehicle propulsion system as shown in the the output voltage of fuel cell stack is conditioned to the complicated with the battery voltage using a power conditioner with which could be step up or depending on the voltage levels of the fuel cells and the battery. Inverter uses to variable the voltage and variable frequency to power the propulsion motor. A battery are generally connected across the fuel cell system to provide supplemental power. So, and for starting the system among the several kinds of fuel cell, such as a proton exchange membrane PEM fuel cell, alkaline fuel cells, phosphoric acid fuel cells, molten carbonate fuel cells, and solid oxides fuel cells. And PEM fuel cells are gained importance for automotive propulsion application for the following reasons: easy start at a ordinary temperature below 100 degrees Celsius, relatively high power density, and some smaller size, simple structure and maintenance, rugged to shock and vibrations. On the other hand, the problem in PEM are the following: the carbon monoxide CO concentrating in the fuel should be reduced to less than 10 ppm, which caused deterioration in cell performance. Typically, the expensive precious metal catalysts are required, and low overall fuel economy from hydrogen generation should be addressed. Next, the power electronic requirements. The power switching devices, electric motors are associated controls, system and component play a key role in the bringing hybrid and fuel cell vehicles to market with reliability and affordability. The power electronic system should be efficient to improve the range of electric vehicles and fuel economy in hybrid vehicles. The selection of power semiconductor device, converter, inverter controls, switching strategies, the packaging of individual units, and the system integrated are very crucial to the development of efficient and high performance vehicles. In addition to power devices and controls, there are several other components such as capacitors, inductors, bus bars, and thermal systems that form a major portion of power electronic units. The packaging of all these units as one system has significant challenges. The US Department of Energy, the US Navy, and the other organizations have funded the development of the power electronic buildings blocks to develop the model system that range of 10 kilowatts to several megawatts, shown as the power similar functioning as the PEB, which is mounted on the Toyota hybrid synchronous drive, composed of an inverter for the air conditioner and inverter for the starter, and the generator for the tractor, traction motor, DC-DC converter for the auxiliary battery, and the DC to DC bidirectional converter. And if you see, this is the power control unit, and we have a engine controlling computer, HVA controlling computer, brake controlling computer, HVAC battery controlling computer, and power control unit, and the generator and engine, and auxiliary battery level, that is 14 kilowatts. So the last conclusion, several technologies are in the horizon to be implemented in the next generation of automobile. There are still a lot of technologies challenge to overcome, particularly in the area of fuel cell vehicles. Major obstacles must still overcome in the area of weight, volume, and the cost of achieve the expected efficiency and performance. Other issues are manufacturable reliability, safety, and durability, and the most important is the value of the customer as a function of cost. The barriers of the introduction most electrical vehicle depends on the economic and not much on the technology. The value of hybrid and or plug-in hybrid vehicle as a great than the cost. This value equation includes a payback in fuel cost saving for the extra cost of fuel adding to manufacture corporate average fuel economy value, vehicles performance and boost amount on onboard electrical power for entertainment features and other conventions, emission reduction, and finally the image of the origin manufacture progress has been made in the area of electrical power and rotating the cost and improving the efficiency of the system. So thank you. As this topic was ended here.